Okay, we're up to section 5, chapter 6, which is about percentages. And so let's start. So we're going to go through a couple of true-false questions. So question number 1, 300% of 12 is 36. So remember, to change percentage to a decimal, all you have to do is divide by 100. And so you would get 3. And to find out what percentage some new number is of an original number, is you take this number, 3 in this case, multiplied by the original number, which is 12. And so when you do that, you get 36. So 300% of 12 is 36, so that is true. Four, when 759.367 is rounded to the nearest hundred, the result is, okay, so 759.367 to the nearest hundred. Well, you take hundredths would be 2 decimal places, tenths, hundreds, thousands. And so you look at this and you say, is this 7 closer to 10 or closer to 0? Well, the splitting point is 5, so since 7 is greater than 5, we round up to the next higher. So it's going to be 367 instead of 366. I mean 337 instead of 36. And so just looking at this, they said false, and I would say true. So what the heck is the difference here? See if I can find anything about rounding. Locate the place to which the number is being rounded. Look at the next digit to the right of the place where the number is being rounded. If the digit is less than 5, drop all digits to the right. If the digit is 5 or 8, drop all digits to the right of the place to which the number add 1 to the digit. So that's what I did. So that's true. So I don't know why they said false. I think I've been rounding long enough to know how to do that. Okay. And 70% is the lowest passing grade on a quiz that has 50 items of equal value. And answering at least 35 items correctly will assure you of a passing grade. So what we're going to do is we're going to take 35 out of 50. So we create a fraction. And if you take that fraction and you multiply by 100, then, so this will give you the decimal equivalent. If you multiply by 100, you will get the corresponding percentage. So we take 35 divided by 50 times 100 is 70. So it's equal to 70. And it says that if 70% is the lowest passing grade, then you're right at the lowest. If it had been 69.9999, you'd fail. I mean, you would, yes, you'd fail. So this one is also true. 10. If an item usually costs $70 and it is discounted 10%, then the discount price is $7. Well, it's going to be discounted $7, but the discount price is not going to be $7. The actual discounted price is you take the original amount and reduce it by 7%. So you take 70 times 7%, which you can convert to a decimal by dividing that by 100. So you get 70 minus, in this case, actually it said 10%, didn't it? Not 7%, 10%. Okay, so 10% in terms of a fraction. Well, we could actually just do it. 10% is the same as the decimal 0.1. You take 10 divided by 100 to get 0.1. Okay, so 0.1 times 70 is 7. So the discounted price is $63 and not $7. So that's false. Okay, problem 13. Calculate each of the following using either a calculator or paper and pencil methods as directed by your instructor. Okay, so what we have is 8.74, and we're going to subtract 12.955. So we're going to end up with a negative number. And yeah, so what am I going to make you do? Use a pencil or not? Yeah, I think we will. Okay. Why? Because you don't always have a calculator. So there's two ways of doing it. Well, the way you would actually do it is you would take the absolute value of each number. This is actually where doing that would work, and I'll explain why here in a second. And I added a 0 in here just so we have something to hold that place. So we would subtract that, and then we would put, since the absolute value of this is greater than the absolute value of that, we'd end up with this result. We make it negative. The reason I'm saying that's better, because if you take 8.740 and you subtract 12.955, it's just, I've never done that before, where you have the smaller number on top. So that's why it's better to do it this way. Okay, so 5 minus 0 is 5. 5 minus 4 is 1. 9 minus 7 is 2. Put the decimal point down. 2 minus 8 is a negative number, so we carry 1 over. So instead of this will become 0, and this will become 12. And so we can subtract the smaller number from the larger number, so you get 4. And then because the absolute value of this is greater than the absolute value of that, the answer is actually negative 4.215. And actually what we're doing here, if you think about it, is we are making this 12, so we don't subtract a smaller number, a larger number from a smaller number in this case. So we're kind of doing the same thing when we look at a problem like that. Okay, 16 is 45.1 times 8.344. Again, what I would normally do is put the number with more digits on the top. I'm not sure if that's what they say in the book or not. And what we'll have is 1, 2, 3, 4 decimal points that we're going to put into it based on this. Okay, now we multiply that. So 1 times 4 is 4, 1 times 4 is 4, 1 times 3 is 3, 1 times 8 is 8. So that's the one part. Go to the next one. 5 times 4 is 20. And we carry the 2. So we have 20. 5 times 4 is 20 plus 2, which is 22. So we carry 2 to here. 3 times 5 is 15, plus 2 is 17. Okay, we carry 1. So 8 times 5 is 40, plus 1 is 41. Okay, the third one, we put 2 zeros. 4 times 4 is 16. We carry 1, because we have 16, put the first digit down. So we carry 1. 4 times 4 is 16, plus 1 is 17. Okay, so that's 17, we carry 1. 3 times 4 is 12, plus 1 is 13. Carry 1, because we had 13. 4 times 8 is 32, plus 1 is 33. It seems like I got too many numbers there. What happened? Let's try this again. 4 times 4 is 16. Carry 1. 4 times 4 is 16, 17. We add 1. Which is, okay, that one's probably right. Okay, I'm still bombed because this is much too small. Okay, let me think about this again. Okay, you got 0. Oh, I know. I forgot to put the 0 right there, didn't I? Okay, 0. And then 5 times 4 is 20. Carry 1, you get 21. So 5 and 4 is 20, plus 1 is 21. So you carry 2. 3 times 5 is 15, plus 2 is 17. You carry 1. And 1 onto 40 is 41. And now we add them. Okay. So you get 4, 4, 3 plus 1 is 4, plus 6 is 10, carry 1. 9 plus 7 is 16. 16 plus 7 is 23. Carry the 2. 2 plus 1 is 3. 3 plus 3 is 6. We don't have to carry anything because it's less than 10. 4 plus 3 is 7. And 3. And how many decimals? We have 1, 2, 3, 4. 1, 2, 3, 4. So we get 376.3044. Okay. According to my book here, I have messed one number up. I don't do this very often, so I'm just as rusty as you guys are. So let's try it here. 0, 20, 0. 20, 21, carry 2. Okay, let's get this. So we get 0, 0, 16. So those all add up to 10, and they have 1. So let me see what's going on here. 45.1 times 8.344. Okay. Did I write the numbers down right? Okay, I'm just going to pause here for a second. I don't really see my mistake, but I guess it's there. Okay, I found what it was. 4 times 5 is 20. You carry 1. You carry 2, not 1. That was the problem right there. So this is actually 2, but that's 2. That's 0. So we get, this becomes 1. So that's the correct answer. Okay, well, I need practice too, so you kind of lazy sometimes. I'll admit that I did it. I get lazy sometimes. Okay, so this is probably good mental exercise. Okay, so what we're going to do is we leave the numerator the same for the first part. We complete the denominators. So what we have is 2.30 plus 1.45. So 0 plus 5 is 5. 3 plus 4 is 7. 2 plus 1 is 3. So this is going to be 3.75. And now we're going to divide out. So let's take 118.5 divided by 3.75. So as far as how many decimal points, we can take that into account. Well, one thing you could do is you could move this 2 units here, and you could add 2. Well, actually, what you do is if you move that 2 units, then you move this 1 and then add another 1. So we can equivalently do this problem. That would be one way of doing it. So let's do that. Now, we say, okay, can you divide by 118? Let me erase the little dot there just so we don't think it's there anymore. So these are the equivalent problems to the original one. Now, 118 is smaller than 375, so we don't put anything here. Then we have 1185. How many times can 3 go into that? Well, definitely 2. 3 is, I'm not sure, so let's just try 3 and see what happens. So if you put 3 here, 3 times 5 is 15. 3 times 5 is 15. Carry 1. 27 times 3 is 21 plus 2. Plus 1. Okay, 5. 3 times 5 is 15. Carry 1, so you get 22. 9 times 3 is 9, plus 2 is 11. Okay, now let's subtract. We get 0, 0, 6. How many times can 375 go into 600? Well, only one time, because twice that is going to be, 300 times 2 is 600. So 375 times 2 is going to be more than 600. So you take this down. And what do we get? 0 minus 5, well, you carry 1, so this becomes a 9. And actually what we have to do is carry 1, but you've got to steal 1 from there as well. Okay, so you're going to have 10. 10 minus 5 is 5. 9 minus 7 is 2. 5 minus 3 is 2. If you add these two together, do we get 600? 5 plus 5 is 10. Carry 1. Go to 0, carry 1. You get 7 plus 2 is 9, plus 1 is 10. And then you get 2 plus 3, which is 5. Carry 1, you were carrying 1, so you get 600. So that's correct. And then, so that's what we get, and then you put a 0 onto it. And 225 is less than 375, so we are in the right direction. How many times can this go into that? Well, let's just think of it as 24 and 4. That's about 6, right? So 6 looks like a good number. So 6 times 5 is 30. 6 times 5 is 30. Carry 3. So 42 plus 3 is 45. So we carry 4. 6 times 3 is 18 plus 4 is 22. And you get a 0 remainder, so it's exactly equal to 31.6. Okay, let's see here. Let's look at the graph, and we're just going to answer one question, which is question 22. So it says, about how much did the U.S. government spend on education and social services in 2005? Well, pie charts always give you the results in percent, so we can read this directly off of there. And then if we take that percentage and multiply it by the total, which is 2.5 trillion or 2,500 billion. So we're looking at education and social services, and that's 3.9%. 3.9%. Okay, so to get an actual number, we have to convert that to a decimal equivalent. So we have 2,500 billion multiplied by 3.9%, divided by 100, gets it into the decimal format, and so 2,500 times 3.9 divided by 100 is 97.5. So it's 97.5, not just $97.5, but $97.5 billion. Okay, we're going to stop there and start a new video.